pleased to introduce Leonard Mlodinow today. He is a theoretical physicist who is good at making complex scientific topics interesting and easy to understand. He has made numerous contributions to various publications like the New York Times, the Wall Street Journal, Scientific American, as well as a range of appearances on different TV shows. He is the author of many best-selling books. Two were a collaboration with Stephen Hawking. He's here to talk to us today about his new book, Stephen Hawking, a memoir of friendship in physics. Now I'd like to welcome Leonard Mlodinow.
Hey, David and everybody else.
Hey, good to see you. So we'll get right into this. In his 20s, Stephen Hawking got diagnosed with ALS, and that resulted in the image that many people have of him in a wheelchair, speaking with a computer voice. And it seemed like a really debilitating thing. Do you think that he was upset by his disabilities?
Well, certainly when he first was diagnosed, he was upset. He went through a period of depression before he was able to accept it. But when I knew him many years later, not at all. In fact, he considered it an advantage. I think it was his superpower. He had grown so much through that disability and changed so much, and I think he felt that he had become a better person. I can explain. Shall I elaborate a little bit? Maybe that's a little bit mysterious. I would say there's a few things. One is that before he got sick, he was kind of aimless and had no passion for life. He did various different things, but it kind of, I don't want to call him a goof off because he was a pretty good student, but for him, that was a goof off. And when he got sick, you know how some people might find God in such a situation. And when he got sick, he didn't know he would live 50 years. He was told he would just live a couple of years. He found meaning in life after that diagnosis. He decided that what he wanted to do was use the rest of his life to investigate the big meaning, the big questions of life and the universe. Where did it all come from? Why is it here? And he found physics, and he really became dedicated in physics and found that he loved physics. And he also told me that he found that later in life, it really helped him focus. Physics is a very difficult subject that you have to work on constantly, and you're running into roadblocks, and you're beating your head against the wall for months or years on end to tackle certain problems. And he found that because he couldn't do so many things, it really helped him focus on what he could do, which was one of which was the physics, and that really made him a better physicist. And I guess I would add one other thing, which is that he was very adaptable, very flexible, and he was able to adapt to his illness. And in his physics, he did that by doing the mathematics a little differently than other people. You can do a lot of physics can either be done algebraically or with functions, or geometrically, sort of with pictures. And it's kind of like the difference in high school between algebra and geometry. And for those of you, since this is a Google Talk, you probably know what analytic geometry is. So analytic geometry treats geometric issues with equations, and Euclidean geometry treats it with illustrations and shapes. And he found that since he couldn't write equations, which would just be a killer and a fatal flaw for me, I couldn't do any physics, but he could work with these pictures in his head. So he took a geometric approach, and that new way of looking at things really helped him in his work. And so there were many ways in which I think he felt that his disability actually was an advantage.
Yeah, there are lots to get into there. We'll talk about more of that in a little bit. But right now, I'll jump back to his life before ALS a little bit. It sounds like, well, let's first talk about how he learned about Newtonian physics and how it applied to billiard balls. What lessons did he take from that?
I think his big lesson was that Newton was an ass. He didn't care for Newtonian physics. I didn't either, to tell you the truth. So I could identify with that. I think when you take physics in high school and you're learning about billiard balls, it can be less than exciting. I think physics, as you're taking your first physics courses, it really starts to get exciting when you go into quantum theory and the really weird aspects of modern physics, not the more ordinary. Newtonian physics describes the everyday world, and so if you're learning about billiard balls, you're not really learning anything new. You're you're learning how to describe mathematically what if you play billiards, you know very well already. So it's not real enlightening. But when you get to quantum theory and all the crazy things, particles, losing their identity or being at two places at once in a way, and in a sense, and all these other things, or curved space, when you learn about general relativity, these are the things that excite your imagination. And so Stephen wasn't thrilled, learning about the Newtonian physics.
It also sounds like in college he was a bit lonely at times, and part of what he did to deal with this was he became a cockswain. Can you tell me a little bit about that?
Well, that's exactly right. I think a lot of kids, when they get to college, are a little lonely. And Stephen, he had some problems in earlier years in school. Kids making fun of him. He was kind of gangly, and I don't know. They made fun of the way he looked or his sports abilities. And when he got to college, he found, like many people do, when they focus on their interest, or they join a fraternity or join a sorority, he joined the crew, and was very good at it. And so he would just sit there barking out I guess right, left, or whatever it is they say to those who were rowing. And he was you could really see there his adventurous spirit, almost reckless. I mean, his coach got mad because he kept getting into crashes and banging up the boat because he was trying to do crazy things. But that's what you can see in his physics later. I think if you look at someone in their younger years, you can then later see the roots of or the image, the reflections of that in their older years. And his physics was kind of like that too. He didn't do conventional things. He was always adventurous, and that's where he made his progress.
That's fascinating. Yeah, I know at one point you said not only did the team not do well at times, it finished races with damaged oars and pieces of the boat knocked off. And very humorous.
Well, if we let Stephen go, that's what happens, right?
he definitely didn't. He was definitely on the adventurous side. And you talked about this a little bit. What aspects of this did you see later when you worked with him?
Well, he was bold in his physics, and he was bold in his writing. So if you look at the advances he made in physics, one of his great strengths was to be unconventional and adventurous, to take risks. Because, I mean, I don't want to go over all his advances in physics, but his most famous was Hawking radiation, where he actually started out trying to prove that nothing like that could possibly exist. And he was quite adamant about that. And his mathematics led him to see that actually it's true. And he was surprised, but he was able to let go of his resistance to that, because that's what the mathematics told him. And when he first announced it to a meeting, it was not met with cheers and applause. People were somewhere between confused and some of them angry that he would say such a thing, because it so violated their ideas. Of course, it became accepted, but you have to have a certain amount of courage and adventure in your spirit to do that. And I should say that it was not just the result that was really groundbreaking. It was what he did to get that. He took general relativity, which is what we call a classical theory. It is not the kind of theory that's a quantum theory. And then he took quantum theory of electromagnetism. So that was a theory of light and electrons and positrons and so forth. And that's a quantum theory, and they contradict each other. And back then, very few people were working on how you might reconcile that contradiction. But he took both of them and used them together, which you have to do very carefully, because they contradict each other. And normally that's not a problem, because we use general relativity for large scale things, for stars and galaxies, or the beginning of the universe. Black holes, we use them for today, and we use quantum theory generally for atoms. So there are two different realms, and physicists were able to get along with two different and contradictory theories, one for each realm. But he found that in treating a black hole, under certain conditions, you really need to use both, and that's where you have to be very adventurous and careful and take risks. And when you work on physics, almost nothing can be solved exactly. you're always making assumptions and approximations based on either mathematical intuition or physics intuition about the physical situation. So people can, attack you and question what you're doing. And so he took two contradictory theories, made all sorts of approximations and assumptions to get some answer, then announced an answer as a very young guy, announced an answer that shocked everybody. And I thought that was a very adventurous thing to do. And by the way, it wasn't obviously eventually accepted, but it's kind of interesting to me that the way it got accepted was people looked at what he did and semi-accepted what he did eventually, but a lot of them went and just re-derived it their own way. There's a number of papers repeating his conclusion that derived the same thing from different angles, and everyone had their own kind of approximations and methods they would use, and that's how it finally became accepted.
It sounds like he could predict the sort of reception he would get based on the way physicists behave in general when new theories are announced. Can you talk about that at all? Or
well, that does often happen. Some of the theories are relatively quickly embraced. Einstein's special theory of relativity, for example, although there were some who never accepted it, it was pretty well embraced from the start. Quantum theory was a whole story of the opposite happening. At almost every step, people said, this couldn't be true. This is ridiculous. Max Planck discovered a kind of a trick to explain something called black body radiation that was important around 1900 in physicists' minds. And everyone could see that his theory worked for that, but no one really thought it was a theory that had any more importance or generality. They thought it was some kind of trick that they would eventually understand just for this situation. It was Einstein who said, no, this is a principle of nature. We have to take it seriously, and it's going to change everything. And he used the same principle to explain something else called the photoelectric effect. That's what he got his Nobel Prize for eventually, not for relativity. But that people had a hard time accepting. Even Max Planck didn't accept that. And Max Planck later wrote, well, that was one of Einstein's greatest mistakes, but he's really smart anyway. So Einstein did that in 1905, and Planck did that about 10 years later. And everywhere along the way until the mid-1920s, where physics really got to a quantum theory that was pretty well developed, people kept saying, no, what that guy's doing or what he's doing is dumb, doesn't work, and they had a very hard time accepting it. And it's very famous, of course, that Einstein in the end didn't even accept what he had wrought, as people took the theory in other directions because the mathematics was leading them there and the physics was leading them there. Einstein himself turned against the theory. So it's often hard to get physicists to accept a new theory. Not always, but it often is. And so when you come up with something new, you have to, you have a certain amount of trepidation and a certain amount of excitement.
I'm going to take a small tangent, perhaps, but perhaps related to the way that Stephen saw things a little bit differently. What was his favorite passage in the grand design? Some fish.
Sorry?
I think you talked about a fish.
Oh, his favorite, not Pat. Yeah, well, his favorite, I think I wouldn't say necessarily his favorite, but one of his favorite parts was what you want me to tell the fish story, because it's okay. Steve, so I went to Stephen after we wrote our first book together. He had read two of my books, Euclid's Window and Feynman's Rainbow. And then he contacted me to write with him because he wanted to do a very, well, I don't know if it's simple, but a very well-defined task. He realized that his book, A Brief History of Time, had so many copies and that people weren't really understanding it or even getting to the end. And he was looking for someone to rewrite it with him to make it more understandable. And he wanted someone whose writing he liked and who also knew physics. And then he read those books of mine, and one day I got a call and I said, sure. So that was a briefer history of time. And so we did that, and it went very smoothly, and it was based on his original book, so it was fairly easy. But then I said to Stephen, why don't we write a book on your latest work? Because Brief History of Time and Universe in a Nutshell, Briefer History of Time, all these books were based on his earlier work, but nothing based on what he was doing at the time, which I thought was very exciting. And so that became the grand design. It was about his ideas of the beginning of the universe in the 2000s and some work that he had published. But he didn't want to just do that. He said, I want to write a book that will present a new philosophy of physics. And that's where the fish come in. So, even though in the book he says philosophy is dead, and we had quite a debate over whether or not we should say that. His idea in the book was to present a new philosophy of physics. And that philosophy is something we dubbed model-dependent realism. And what that means is that, so there's an argument in philosophy about how real physics is. There's the people called the realists and the people called the anti-realists. And the realists say that there's an objective universe out there, and physicists are faithfully observing it and transcribing, writing down a theory that describes that reality. The anti-realists, they say, no. All of the people are doing in their theories is organizing their sensory input. So a theory is more of a way of structuring or organizing what you're learning about what your senses take in, but you don't take it more seriously than that. An alien or a bat or a goat or another animal or a very intelligent animal from another planet would have a completely different brain structure and therefore a completely different set of descriptions that has nothing to do with our physics, and it would describe their sensory input, and there's not necessarily any objective common reality behind that. So that's the two camps. And Stephen was kind of in between. He saw that in physics we have different theories, sometimes for the same thing, that treat that situation using different concepts. So he said he believes something called model-dependent realism, which is that you shouldn't argue about what's real or not real, but that you should take each theory as representing a certain reality, and it's okay if you have different views of the reality, and they're all in a sense real. So that's the best I can do. It's not being a philosopher. That's how I would describe this model-dependent reality. And one thing that makes it really, I think, come to life is this fish story. So the fish story is it's about a fish, a world of fish that live in a curved bowl, and these are intelligent fish, and they create theories about their world, and because of the difference of the index of refraction between the air outside the bowl and then the glass of the bowl and then the water inside, light rays that go into the bowl, they bend, and because the outside of the bowl is curved, this distorts the view the fish have of outside events. So these fish scientists would have some set of laws for what's inside the fish tank, but then, like some of the ancients, they would have a heavenly realm where they would say outside, they would know it's a fish tank, but in the heavens and outside where we can get to, the laws are different, and those laws would be different because we know standing outside that's because the light is being curved as it enters the water. So they would have this very complicated description of, say, where we say Newton's says that something without any forces acting on it moves in a straight line. Theirs would move in a certain curve because of this diffraction as the water refraction, because as the light rays come into the water. Fine, they would have that. That would work very well. And then someday, some new fish physicists could arise and say, wait a minute, there's this idea of refraction, and that fish could have reasoned it all out and said, no, outside things just keep moving in a straight line just as they do inside. But the reason it looks curved is that there's some medium that's outside that's different from the medium here, just like, say, the ether that people used to talk about. So our world has a certain medium, their world has another medium, and this fish scientist could say there's some boundary which has curves, and the fish scientist could explain it all that way, just as someone a human on the outside would explain it. Okay, now look at it from the fish's point of view. They have these two theories which describe the same perceptions that they have, but completely different realities. To one theory says that there's different laws outside the bowl. The other theory says the laws are the same, but there's this curvature that happens when light enters. And of course, that doesn't seem so shocking to us because we're humans on the outside looking at everything. We're like God to the fish world. But to the fish who can't get outside, don't know whether it's real or not, can't ever get there to see, and can't look down at the situation from the outside, there's really a quandary. Which of these is real? And so Stephen would say, well, they're both real. The one is not any more valid than the other. You use one in certain situations if it's easier or more, or clarifies things better. You use the other's description when you want to use that. And you shouldn't debate about there is a reality, but there's a multiple realities, and the different theories can be put together to apply to the same thing. And that the reason that was important to him was his work really involved issues like that. Modern physics has a lot of theories that involve both observable things and non-observable things. It's a mistake to think that non-observable phenomena have no place in physics. You base your physics on observations and you test that your physics according to the observation, but the mathematical structure that you build might have other predictions that it makes that you can't observe. And if we believe, if the theory seems to work in the realm that we can observe, we tend to take seriously to some extent the predictions it makes about what we can't observe, at least when we're musing about the nature of the universe. And so it's really an important issue in physics today if you want to understand the philosophy of physics.
Yeah, that makes a lot of sense. I found this interesting to hear about how your editing went in the book, and that Stephen Hawking was interested even in the small details, the wording of it and various things. What was the last edit on the book that y'all did?
Well, okay, so again, forgive me to give you a little background. So we had, when we started writing the book, we had a deadline, and we didn't make it. We had another deadline we didn't make it. We just kept going past the deadlines because Stephen really focused on every word of the book. So when I wrote a briefer history of time with him, it was pretty easy going, and it didn't take years. But in the grand design, I think because it was original, we really debated everything, the outline, the structure, not only the content, but the way we said it in each word, and the pictures, the illustrations, and so it was slow going. And eventually, our publisher, I guess, lost patience and said, announced that we didn't even tell us, just announced that the book was coming out with a certain date, which meant we had to be done by a certain date. And suddenly, we had another deadline, but this one seemed more serious because it seemed like there'd be repercussions if the bookstores don't get the book when they were promised it. So we had this deadline. 8 p.m. out in Cambridge time, it was 8 p.m. on a Friday night. And so that morning where I get there and I'm like going, oh my God, I don't see how we're going to get through all this. But if we really, we were near the end, and if we really put our minds to it, I suppose we could get there. And we're going, the clock's ticking. And every time if I say, oh, Steve, it's 5, he would just like either ignore me or roll his eyes. He didn't want to hear anything about it. And he's still talking about like individual words and stuff. And I'm going, after 4 years of working on this, we have like 3 hours left, and, it didn't seem to matter. And then, at some point I had to step out for a minute, and I told his assistant, you better extend my stay at the college and let's rebook my flights back. We're obviously going to blow this deadline. And, and I'm like, and it's now like 2 minutes to 8 or something. I walk back in and to continue talking. And now he's talking about one of the pictures, whether the illustration of a drinking straw in one of the pictures was realistic or or it was too long. And I'm, so I don't know. I don't remember what that picture looked like. And, he doesn't have it in front of him, but, I guess he just remembers everything. So I have to find the book, look up the picture. Oh my God, yeah, it is a little long. I mean, is that really, it was a very serious illustration about string theory. So it's not like it was there for its artistic effect, but it did seem like too long. So I write that down, and now it's like 8 o'clock, and I'm going, okay, what's next? And then he says, it's 8 o'clock, we're done. We're done? You're just cut, then he said, like, sometimes I need a deadline. But I had known that, I would have told them to ship the book, 2 years earlier.
That's great. Soon we'll start to take some audience questions as we get them, but we'll go on for a few more questions and all. What idea or creation was he proudest of?
I'm sorry?
What idea or creation was Stephen proudest of?
Oh, it's interesting because Stephen is most famous for his work on the Hawking radiation. but it was an advance he made after that called the no boundary proposal that he thought was his best contribution. And that had to do, so in Hawking radiation, what he did was he applied quantum theory to black holes for the first time, which people, or basically for the first time. There may have been some other minor papers about it, but it was the first major application. And until then, people had, including Stephen, had treated black holes just using general relativity without trying to see if quantum theory implied any different phenomena. And then his work in, it was I think 1981, 83, on applying quantum theory now to the beginning of the universe, which also had been treated only classically using Einstein's equations. And that led to his work on what's called the no boundary proposal. And that was his favorite, his best piece of work. And that had to do with, he realized in that work that the Big Bang, which was his, the famous part of his PhD thesis, it was the chapter 4 in his PhD thesis, was proving that Einstein's theory demanded this Big Bang under certain conditions. That the Big Bang had to happen from that the universe, it's smaller and smaller as you go back in time, and it eventually shrinks to just a point where the density is infinite, the temperature is infinite, and that's the Big Bang. If you play that backwards, it's the Big Bang. Well, he realized that quantum theory smooths that out in a way, so that doesn't really happen. And as you go back in time, what happens is time, because of general relativity and the interplay with quantum theory, it starts to lose its character. Time seems to us to have a different nature than space in our everyday life and our intuition. And as you go back in time, though, it starts to change and look more like a dimension of space, and that smoothed everything out and really eliminated that singularity of the Big Bang. So that was his no boundary proposal. It's not nearly as universally accepted as his Hawking radiation is, but that was what he thought was his most important contribution.
Would you say that he thought physics is life to him?
Well, physics was a very large part of his life, and it was his passion. But he also had passion for people, and he found his relationships to be extremely important, and was really a people person. He really valued being around people, and my son told me once when he was in high school, basketball was life, and I said to Stephen, for you, physics is life, and he said, no, love is life. So I thought that was very touching and a statement that gave me a lot of insight into him.
Yeah, it sounded like he loved people. He liked the attention that if they gave it to him. If you could choose one word to describe Stephen, you could choose multiple if you like, but if you could choose one word, what would it be? There's two. I guess you could say inspirational, but then I'm not telling you how. You could say, I guess I would say optimistic, resilient, brilliant. So I give you 4. There's a lot. I wrote a whole. That's why I wrote a whole book on it, because it wasn't just one. There wasn't just one thing that I learned from him. There were so many things, so many lessons. I mean, not only does his life and all the. In the book, I try to show you Stephen as a human, as opposed to what you saw in public appearances, where everything was orchestrated and sanitized and mythological, or in the movie, a lot of it was. In his everyday life was very difficult. If sweat was dripping down his brow, it tickles you and you want to wipe it off, but he couldn't do that. Either it would just have to take it, or eventually his carer might see it and wipe it. But that's just one example. Minute after minute, the way he was fed, he had to be fed, going to the bathroom. You can imagine at night, he can't move or turn. So you get these aches and pains and you can't do anything about it. He was constantly being challenged by his existence, being challenged not to be tortured. A lot of these things that he endured would just torture any of us. And he learned that his happiness and his feeling about himself is really all up to him. It's in his head. It's kind of like the Stoic philosophy of the ancient Greeks. And he really
was able to take command of that and to rise above all that. And that gives you so many lessons. It teaches you, to put your own problems in perspective. It teaches you that you can do the same thing and you can take charge of your own happiness. It teaches you what you can accomplish. He can't write equations down. That is what physicists do all day. And yet he was able to make accomplishments. I wrote in the book that he taught me that a lot of us are limited in what we accomplish only by the limitations that we give by what we imagine that we can do. That if you can think that you can do something bigger or better, then you can actually do it. And it's just your assumption that you can't that stops you. So there's a lot of lessons there.
Yeah, it makes sense. When you're talking about the sweat going down his brow, you reminded me of a story that you told in the book where you tried to help him with this one time. Can you tell me about there?
Well, I did. It was at the very beginning, and his care had stepped out to the bathroom, and I was left alone with him for just a couple minutes, which was not, later on that would be pretty common, but usually not done that soon. And, when I wasn't sure, didn't know him that well. But anyway, I saw a drop of sweat and I asked him if he would like me to wipe it. And he goes like this, which means yes, or yes, He had a lot of facial expressions and amazing nonverbal communication. And so I went to do it. I dabbed a little bit and then I saw it a little bit more and I started going back. I guess he could sense that my hand was going a little fast, and then he started making some face, which I didn't quite get in time. But when I hit him, his head just like rolled because he had no muscular control. So I kind of knocked his head over. And, I don't know, I can imagine that if you ever had a neck ache, I mean, that I shudder just to think about how that feels because, you're stretching the tendons. Anyway, and he makes a face like that, which was not a good one. And I'm like freaking out. What did I going to do? I just damaged Stephen Hawking. Oh my God. And I take his head and start to, stand it up straight. And then his glasses slid and he had a sensor on his glasses, which was how he typed by twitching his cheek. And that sensor would pick it up. And now, but it had some alarm on it because it was outside of the standard of the distance it was supposed to be. Now, so alarm is going off. I'm moving his head around. I'm going, oh, and I was just like new there. I went, oh my God. And then people come, Judith, his assistant, comes running in, the carer comes running, and it's like, anyway, yeah.
Okay.
Thanks for asking.
Oh, yeah. Let's take an audience question. We have one here. Maybe it'll get put up, but it's, what is your most memorable moment with Stephen?
Yeah, I don't know if I can say a most. I think that the book is a series of those memorable moments. Some of them that I've mentioned already. I mean, the first introduction. Well, it wasn't really. I had worked with him at Caltech. I was on the faculty, and he would visit. So when we worked on A Briefer History, but it wasn't as intense or as much because it wasn't. I could just write stuff, send it to him, and so forth. This was my first real engagement with him. So that was a big memorable moment. The philosophy is dead. We had a debate on that. That was, the very end. I mean, the book really has, that's what the book is. It's memorable moment after memorable moment. It's really, there's some doozies in there. It's a little hard to, it's hard to pick one. They're all, it was over many, many years, but there's so many moving and interesting things happen.
Yeah, it sounds like this whole thing about philosophy is dead is played into his desire to have statements that have punch in them.
Yeah, right. He had a flair for publicity, I think, and for publicity I don't want to say that it's not so much publicity as it is kind of like tweaking people or, getting a response, not in a bad way. And but he was quite a character in terms of like, he liked to, he liked to do that, to just get a reaction from you. So I think that I think he appreciated that part of that. He'd rather do that than be safe.
It makes sense. And now we have a second part to that question. What's the most important life lesson that you learned from Stephen Hawking, and is there any story behind that, of course?
Well, I think that's what I was talking about earlier. I learned the lessons of perspective in your own life. That if you're getting, let's say, annoyed because it's hot outside and your air conditioner broke, get over it. you know, that you're in control of your own happiness. So if you think that, if material things bring you happiness, and then something happens and to one of them, you can't get them, or you're dependent on other people to be, for what you think of yourself, you should work, at least for me, work on that, take charge. I can be in charge of my own happiness. That the lesson that I can accomplish things that, one of my biggest limitations is just not thinking I can accomplish it, and all these were lessons, big lessons.
Yeah. If you had reached beyond physics to his whole life, what do you think you might say that the thing that he was proudest of in some way?
Well, I think his children. I think he had a lot of love for his children, and was very proud of the children that he had, and they brought him a lot of joy.
Sounds good. Let's go to another question. We'll go with this next one. Were there moments in which you disagreed with Stephen's theories, and how did that go?
Well, we would debate things. Now, so the theory that we were writing about was something called top-down cosmology, which was a sequel to that no boundary proposal, where you treat the universe in a quantum way, and the conclusions that you draw from that, many universes starting out, and most of them recollapse, they have different laws, etc. That's what the whole book was about, and what that means for the world. And I can't say I would challenge him if I thought something didn't make sense to me, but can't say that. He would explain why it does make sense, and I would go, oh, okay. I don't think I was able to punch any holes in his theory, but it was kind of interesting because the theory was being worked out at the time. So at one point, I was back at Caltech, and I wrote a few pages about some aspect of the theory. And I even went up to Santa Barbara to Jim Hardo, who, by the way, was the co-creator with Stephen of the No Boundary proposal back in the 80s, and was also working on top-down cosmology with him. And I went to see Jim because I didn't understand this, and I wasn't going back to Cambridge for a while. So I went and talked to Jim about it, and Jim explained it. And I went back and I finished writing up that part, those pages. And then I get back to Cambridge a couple of months later, and the way we would work is, when I was there, I would go over his pages, which I had already read before I got there. He would go over mine, which he was supposed to have already read before I got there. And then we would, go over word sentence by sentence, and then move on, maybe move forward a little bit, then decide what we're each going to do when we split up. And then I would go back home, and so we would go back and forth like that. And so I took these pages. I'm back in Cambridge. I'm going over the passage that I read with him. And we get into a big argument because he's telling me that it's wrong, and I'm explaining to him why it's right. And not that I thought I could ever out debate or outthink Stephen, but I was pretty sure of what I was saying because Jim had explained it to me, and we had spent a whole day on it. So I'm thinking, and finally, after like a couple hours of this, and it goes slowly with Stephen because he can only express himself at 6 words a minute. Now that's okay for some things because I can see what he's writing and maybe finish the sentence, or you can play 20 questions, yes and no. And there's, he had a lot of nonverbal communications. For everyday life, things could get sped up a lot, but for very technical physics stuff, it was hard to speed that up. So we spent a few hours on it, and then at the end, I think he just realized, oh, yes, he said, that's what I told you last time you were here, but we realized it's wrong, and this is what we figured out is the new way of doing it. And so in between, when I had talked to Jim, they had changed their mind. Jim didn't tell me. Stephen didn't realize, I guess, for a while what the problem was. And yeah, so, oh, well, that's why I was sometimes pulling my hair out, right?
It's challenging at times. And it sounds like even though you possibly
could look over it. You see, these are Stephen parts that I just pulled out.
Yeah. Well, we'll go to this next question. Just curious, how emotional was Stephen, given that you mentioned he was a people person, yet spent immense time in research?
Is there a scale from 0 to? He had, the emotions you'd expect of a person. I mean, I'm not sure. He was not a cold. He was a very warm person. He was a very feeling person. I think he felt both his passions in love and with his family as strongly as his physics passions. But I don't know really how to answer the.
You mentioned one occasion in which you made sure to have an accessible bathroom in your house, and the reasoning for that. Why was this?
Oh, well, of course, and accessible stairs too up to the house. So,
Yeah.
Because Stephen was in a wheelchair and he couldn't get in otherwise. So the carers told me, well, we can get a few of us could either lift him up and then bring the wheelchair up. It's a very heavy wheelchair, and it had a battery, and there were a big battery in it and so forth. But a computer, but. We could either bring him in the wheelchair separately, or we could get enough to get 4 people maybe and take the whole thing up. But I knew that he was very sensitive about disabled access. He was a very strong advocate for disabled rights. And I wanted to show him that I respected that. And of course, not most homes are not, unless you have someone disabled, they are not wheelchair accessible. But I managed to get have a ramp built that fit those stairs to get him up. And so I think he appreciated that.
It was very considerate. In the book, you also mentioned a story that you felt it sounded like warned you against not having accessible when he went to a restaurant where they didn't have an accessible bathroom.
Yeah, he did. He went to a restaurant. This was in the 70s, and they kind of snidely told him, no, we have no wheelchair accessible toilet. He asked his carer, she didn't know exactly why at first, but he said, I want to go this way, that way. He had her wheel him around to the back of the restaurant, and then he insisted on taking his pee there. He did that into a plastic bottle, and then he insisted that she dump it out into the bushes, and the cook runs out and starts screaming at them, and he starts screaming back because he could adjust the volume on his voice synthesizer, and he made it really loud. I just kept saying, disabled toilet, disabled toilet, disabled toilet. Yeah, and a year later they went back and they had one.
It seemed to work.
It seemed to work.
Yeah. So we'll jump back and get this question. Most of our questions have been, tell us about Stephen, because that's what your book is about. But what would Stephen say if we were interviewing him about you?
Oh, kind, brilliant guy. I loved him. I don't know. That's an interesting question. I don't know if I could answer that for anybody. I think he found me to be, a good friend, someone that he could talk to and relate to, and I know that he enjoyed writing with me, or so I was told by other people who were around him who didn't have to say that. It's not like I said, does Stephen enjoy writing about me? They would come up to me and go, oh, he so enjoys, he's so happy to have you here and so forth. So I think he enjoyed our relationship, our collaboration.
Yeah. What is, I'm picking up another question from the audience. What is one thing Stephen is not known for, but you think he should be?
Oh, well, there's a physics thing, and there's I guess there's one thing in the physics world that I'll just throw off, which is not usually talked about because as much as his other, that has to do with the event horizon. He made a very important step early in his career, and how you define that. That's the border of a black hole. But I don't. That would bore everybody to get into that. But I think that what he's not known for is the things that I'm talking about in the book. People, you see him on TV, and there's a question, he answers it. You don't realize what he has to go through to answer it. I didn't explain, I guess, how it works, but he has a sensor. Earlier on, he has a sensor on his hand. He could still move his thumb like that, but later he would twitch his cheek. The sensor would be on his glasses, and on his computer screen would be a list of letters, rows of letters, and the cursor would go from one to the next, and he had to click at just the right time to catch that row, and then it would go from letter to letter in that row, and he would click to catch the letter. And after he had a letter or two, it would suggest words. So you could do another click to bring him to the list of words, and you could pick word number 7 or whatever. It was a very tedious process that, and he had to have tremendous patience, because sometimes you want to click 6 and you'd click 7. Now you got the wrong word. Now you've got to go and find the erase button and the erase word button. And it's just very tedious. And it took about 6. So 6, he could do 6 words a minute. That's a minute's worth. That sentence is a minute's worth, right? So can you imagine the iron will, the patience, the kind of inner strength he had to sit there and do that. And that's not what you don't see that in when you see him on TV, because he's had weeks to write the answers to these questions, and he has them there, and he just clicks answer, answer 1, answer 2, and they come out all pre-formulated. But I think what it was like to be with him, what his everyday life was like, what his friendships were like, his family, how he did his physics, not the physics that he did, but what how he did it, how he related to the other faculty and his students. And all these things are things he's not known for, because people, biographers generally don't know, because they're writing a biography. They weren't there. The media doesn't want to talk about that, because they want to talk about the issue at hand, whether it's his physics or something he said about aliens. But I think that what he should really be known for is his life, how he lived it.
Okay, our next question is, how will you tell a child what physics is about from your experiences as a physicist and working with Stephen?
That's a great question. So I would say that physics is about understanding where all this came from. So you look around you, you have a house, a playground, parents, you have an earth. You look at the sky. What's that in the sky? What is that? What's that bright thing? What are those little dots at night? Physics is about all that. Like, what are all these things around you? Why are they there? And why are you here? How did we get here? Where did it all come from? I think those are the questions that Stephen dedicated his life to. But I wouldn't say physics is about electrons or photons or transistors, building computers that Google can use to can put software on, or those are things that physicists do, and those are things that are byproducts or outgrowth of what we learn when we ask the big questions. But to me, physics is about all those big questions, and Stephen's research was on that, and a lot of my research is on those questions too. So, in interacting with him, I think I always felt that that's why I got into physics. But working with him really focused that for me, because that was very explicit in his work and talking to him, that these were the questions that he wanted to uncover. This was the gift that you had if you could do the mathematics and understand the physics. The gift was that you were able to make a career and make progress in answering these questions that I think kids, I think, marvel about. I mean, when I was a kid, I would lay there and go, wow, I would think about those things. I remember hearing when I was, 12 years old or something, about curved space, and that just so fascinated me. And I had been learning about geometry and the 180 degrees of the triangles, and that, they teach you that. It's like it's a doctrine. When you get it in high school, and I think I was learning about it before that, no one ever mentions that this isn't the way it has to be. This is in high school, everything is just the way it is, right? But it doesn't have to be that way. And when I learned that space could be curved, and what does it mean to have a curved space, I was fascinated. I found some old book called non-Euclidean geometry. I remember reading it in like 7th or 8th grade. And I was, oh my God, it was like science fiction for me. It was science, but it was fictional, because no one told me this could be true, and suddenly it's going, it's better than science fiction, because you're discovering stuff that's true, and it's weird. It's just as weird as science fiction. So, and I think Stephen and I were like soulmates in that sense. And I think his colleagues, everyone who works in those fields, I think they feel the same way.
Um, yeah, let me ask. I think this will probably be our last question, and I'll take our last question. What did a talkative bartender in Cambridge who gave you a free beer have to do with Stephen Hawking?
So there was okay. So with Stephen, because in the morning it took a lot to get him up. Not it takes a lot to get me up, but not for the same reasons. He had to be bathed and dressed. That wasn't all so easy. His various medical things, his vitamins, feeding him. So it took him quite a while, and so he'd get into work around 12 usually, and he'd look over we call the archive in physics. It's where people send their manuscripts, and he did that almost every day. He would see what the latest physics work was being done and so forth. And anyway, it took a lot till he was finally ready to go. He'd be ready to go, maybe 12:01, maybe 2 on some days. And then we would work fairly late. And so, oops, I got so involved in that part. I blanked out the question.
It's okay. I was asking you about a talkative bartender who told you actually about black holes.
So when Stephen first got into this, no one talked about black holes. It was not even physicists. It wasn't really part of the mainstream. People thought you'd never see a black hole, or you never see the beginning of the universe. And since I worked so late at night with Stephen, which is what I was getting at, we would work pretty late, and then we'd have dinner and get done around 10. I would sleep. I was coming from California, so I changed my hours, and I would go to bed around 2 or 3. So I needed something to do at night. I would go to this bar, which was supposed to close at 11, but they had this funny way of doing things where they closed their doors at 11, but if you got in before 11, you could just party on till whatever time. So I'd go into that bar at night and have a few drinks. And this shows you how physics has changed, and largely due to Stephen, how black holes have changed so much, the study of black holes. Back when he was doing it, nobody cared, not even physicists, right? Now, the bartender is a black hole aficionado, and he starts quizzing me about black holes. He finds out I work with Stephen. He wants to know about black holes, but even more than that, he doesn't just want to know about black holes. He's a very talkative guy, and as I start telling him about black holes, he picks it up from there, and he starts telling me about black holes, and he goes on and on and on about black holes, and I was mostly right. So I remember thinking, like, what a weird situation this is, and because of Stephen, that he took a field that even physicists thought was like, they thought it was boring, unrelated to anything that had no relevance for us. And he, not exactly single-handedly, but he was like one of the big leaders who took that nothing and made it to where you go into a bartender at midnight for a drink, and the guy's an expert on it. So I thought, and of course, Cambridge is like that. That you'd be surprised. You sit down, and the people all around you are all like professor of African economics or a string theorist. I mean, it's not, some of the drinkers were like that, but to find that even the bartender was like that, and that black holes was what's his specialty, I just thought, well, that's what Stephen did for the world.
Okay, so the book is Stephen Hawking, a memoir of friendship and physics. I really enjoyed reading it. I liked hearing about his humanity as well as his brilliance, and I hope our viewers will too. Could you hold it up so people could see?
Oh, yeah, sure. Here's the book.
Yeah, so there's the book.
This part, yeah.
Yeah, so thank you for talking to us about it today.
Thank you. It's been fun.